Hi, my name is Reza. I am an R&D engineer in Artium Technologies. We are located in Sunnyvale, California. What we do in Artium Technologies, we make instrumentations that measure the size, the velocity, and the shape of tiny particles. PDI is a system that you use whenever you need to measure the diameter and velocity of round particles. And it gives you a very accurate measurement, the best and state-of-art method in the market, and globally is the mostly accepted method that is being utilized in many applications, such as pharmaceutical, auto industry, manufacturing processes, inkjet printers, or anywhere that you have a spray or a stream of droplets that you need to accurately measure the size of. What I'm going to explain today is how one of our systems called TK works. The difference between this PDI is that in this one, the transmitter shoots a laser out and the receiver are contained in one package as opposed to having two separate modules. Therefore, it doesn't require any alignment. We align it here in factory and we ship it to you and you can turn the key and start using it. The TK is a 1D system. It means that it measures the size of the droplets and it also measures one component of velocity. So I'm going to introduce you the components of this system. We have the optical head that contains the laser beam, the transmitter, and the receiver contained in one package. We have the computer and the monitor and the mouse and keyboard. And we have the signal processor. Now, the oscilloscope is not absolutely necessary, but we recommend to all users to have them available at their facility when they're doing any type of test, because by the quality of the signals on the oscilloscope, you can tell if the system is working properly and the alignment is good and everything is in place.
Here's the laser head. We have an optical component that splits the laser into two beams, and then we use front lens to cross those beams, and the point of crossing is where the measurements take place. At that point, we have fringes, and when the fringes are formed because of the laser electromagnetic interference, and every time a droplet passes through those fringes, it sends a signal to the receiver. Here come the droplets. You see the scattered light going across the room, and in an offset angle, we're going to have a receiver. So here's the difference between the large droplets and the small droplets. Each droplet acts kind of similar to a lens. So smaller droplets are stronger lenses and they have shorter focal length. So they create or they image the fringes to a different magnitude into the receiver. In the receiver, we have 2 or 3 detectors, and using the phase shift between 2 or 3 detectors, we can calculate the magnification of the fringes into the receiver, and from there we can calculate what the diameter of the droplet is. Here you can see the transmitter, you can see the receiver, and in this receiver we have 3 detectors. So the scattered light enters into the detectors, and by using the 3 signals and the phase shift between them, we can calculate the diameter of the droplet. D1, D2, and D3, these are the signals that we use to measure the droplet size. You can see the phase shift between them, and that relates to the space in between the detectors. Then we send those signals into the processor, and after some processing of the signals, we send those into the computer, and the software does the final calculation of the droplet diameter.
The TK is one of many instruments that Artium makes that uses PDI method. The TK itself comes in 6 or 7 different packages and optical layouts to fit different applications, but we can also customize them to fit your application. Thank you so much for watching.